Hey, good evening, everyone. Welcome to week 8 of Web Design DeCal. First, let's go through some quick administrative announcements regarding grading. So grading is a little bit all over the place for us right now. As of right now, I think only 3 groups have been graded for their midterm projects. So if you're still waiting on that, bear with us. We'll get those out to you as soon as possible. Also, if you have stuff from like homework 1, homework 2 that's still not graded yet, we'll get to that right away. Or it may have already been graded actually just now, because we were working on those just now. Let's see. Is there anything I'm missing? Evals. Be sure to get your evals in for your group mates from the midterm project, because that was the only homework you had actually for this week. So actually, the more you write about those, the better, so that way we can get a better sense of how to grade each one of you, because it's sort of hard to tell who did what when it comes to a group, as I'm sure you might expect. So today is a little bit different because for the first time ever, you have the option of coming here. That is, you should come here if you don't know anything about programming at all, like you're starting from a clean slate. Because the thing is, like if you've taken sort of the 61 series and you know the basics, then this might go like extremely slowly. But the thing is, this will also go really fast. Actually, I think it's pretty much, in a way, you can almost think of it as 61A in a lecture. So don't be intimidated, because I'm a little under the weather right now, so I'll talk a lot slower as a result. So that'll help you out. But otherwise, please ask me any questions you have at all, because I hear that sometimes I assume that people know things, and I just sort of say things like render, like, oh, everyone knows what render means, so render. And then people are like, what? What does that mean? And it just, yeah, just stop me in case I say anything that I think that everyone knows, but they don't. But anyways, so today we are completing the Trinity, right? So we finally, we went through HTML and CSS, and now we're going to start JavaScript, the official and only scripting language of the web. And actually, more broad than that is, in terms of sort of the course roadmap, we're basically taking a sort of diversion today. We're going to go actually learn some basic things about programming, sort of a broad overview, so that way when you look at JavaScript code, you'll know what things mean. So this course actually, we actually use something called jQuery more than we do JavaScript for web elements, and jQuery is really built with JavaScript. So we thought that the best way to teach this was to first give an overview of what JavaScript is like, and then starting next week, we'll start to use jQuery, the library that's built in JavaScript, highly popular. But for now, it's all JavaScript and programming in general. So just in case you guys didn't know, JavaScript is not the same thing as Java. I know it's sometimes really hilarious when you go into Berkeley job listings, and people are like, you can have 5 years of experience in Java or JavaScript. They're the same thing, right? But they're actually not. And so when people make that mistake, it's really funny. It's mainly used for selecting things, kind of like how CSS does, where the main foundation of this class is really we want you to be able to select elements on a web page and make them do things that you want them to do. And as you might expect, JavaScript does that. So here's just some examples of things that you can use of JavaScript for. I don't know if any of you guys saw Coin, but this was like sort of a product that people, it was just kind of viral maybe a couple months ago, or maybe about a year ago. But basically, all your cards are on one card, right? So you can put all your gift cards and credit cards. And they had a really cool site. So you just scroll, and as you scroll, all the animations happen based on where you are on the page. And you can even do it backwards, too, so everything, rewinds. Of course, this is only possible when you know a lot of JavaScript. And so another cool example is modals on Facebook. So here's a term that you may or may not know, but modals are basically when the entire page turns into a sort of carousel of photos, or just a sort of slideshow of photos where they're like left and right arrows, and then you can sort of swap through them. In case you didn't know what those are called, now you know we call them modals. Alternatively, you can call them carousels, but I think modals is probably a better term. In general, actually, modals I think actually refers to not just photo slideshows, but also just anything that sort of blacks out the page and focuses on one sort of central element. In this case, Facebook has photos, right? So in case you're looking around, you can find that too. Any kind of drop-down menu that you've ever seen on the web most likely was built in JavaScript, including the ones on Instagram. Also, here's a really cool one. This is an interactive resume, and it's really interactive. So I'm just scrolling. I'm not doing anything else. Like I'm not pressing any arrow keys. But as I scroll through, various things pop up. And this character, even like if I go backwards, he goes backwards too. But he just goes through like all of his. This is a resume, by the way. So he's showing off like what skills he has. But it's kind of obvious as you're like playing his little character that he's really good. And at the very end, he goes in a hot air balloon. He's done. Kind of cool. So you might be thinking right now, ooh, intrigue, how to use. So just like with CSS, you have to link your HTML. Within the HTML, you should link the JavaScript. And here's the syntax to do that. It's pretty straightforward. You basically you have to specify the kind of type of the file that you're linking to. So it's text/JavaScript instead of text/CSS. And also you have to have like the path. So we don't use href anymore. We use source, which is the src. So just so you don't accidentally make that typo and you're like, oh, it's not linking, we make sure you're using source. Tomas, do you have a comment about that?
Yes. You don't need a type anymore.
Oh, OK. All right. So Tomas says you don't necessarily need type anymore. So you don't necessarily need that. But yeah, so you put the path to your JavaScript file. And so here's another thing, too. There's something called a console. A console is where you can type in JavaScript, and then it'll immediately sort of do the JavaScript that you typed in right on the page. So and the way you can activate the console is you can do this on any page, but it's all within the web inspector. So in case here's web inspector, you right click, and then you hit inspect element. And here's my web inspector. So we're all familiar with elements, right? Because that's where we did all of our, here's all the HTML, here's all the CSS. But now, if you go into console, you get this. I'm going to zoom in. You get basically an arrow, and allows you to type anything. And so, you can. Here's where you can type in some quick JavaScript, and it'll actually run right on the page. So that's super convenient in case you forget like little quirks about JavaScript and you just want to sort of type it in and see what the result is. That's how you do it. So just one more time, you go to inspect element. And so this is your standard web inspector, but you go all the way to the right, and the very last thing should be console. So this will actually be really helpful. It actually be, it help you guys out a lot actually if you typed in the commands that I go through in the console as we go. Just so you can follow along. So, let's. Oh, question.
Well, it was cut off. The last command you used was alert, right?
That's right. Yeah, I'm actually going to talk about that right now. Basically, I first want to go over some instant gratification parts of JavaScript. So, like, here's things you can immediately see the results of, so you know that what you're doing is actually working. And the first one is indeed alert. So this is basically a function, and this is a term that I'll go over more later in this lecture. But it's a function, or a sort basically something that takes in a value and then it does something. In this case, the value that I've given in is this message in quotes here, and this page is alerting you. If you wanted to, you could try this out on your own using the JavaScript console within the web inspector. So make sure you type it in just like this. And what should happen is that the page comes out with one of these classic sort of alerts that you have to like close. But that's actually how these are done. Another thing that I think is really important to know is comments. So just like previously within like HTML, how there were those comments. Like I said, code is for humans and not really for computers. So if you want to write down things that are important, be sure to comment them in. Or if you want certain things to not run, just comment it out. And one last really nice and quick thing that you can learn is something called logging. Another way of saying this is printing. So the way you do this is quite straightforward. It's console.log and then some message in quotes. What this does is after you press enter, it just shows up within your console, printed. And you might be thinking like, well, why is that necessarily very important? It doesn't show up on my page, so why would I want that? Well, when you get to like debugging, which is the process of like fixing errors in like really large JavaScript applications, then the best way to test really is just sort of print out what certain things are. So that way you can test your assumptions, like, is that really doing what I thought it was doing? Is that really the outputs that I wanted? You can print them out now. So that's what console.logging is for. But now we're getting into the sort of 61A in a nutshell part. So here we go. Please stop me like whenever you find it necessary. But fundamentally, within computer programming, when you're trying to design anything for computers to understand, you sort of want it to be really non-ambiguous, like totally without any ambiguity at all. And the reason for that is like, if you told one of us, if you told like a human being, something that had multiple interpretations, the human would sort of use common sense and say, oh, that's of course what they meant. But computers obviously don't have any common sense. Therefore, you have to be like if you're designing any programming language, it has to be like, if it's a good one, it's super sort of straightforward. One of the parts of programming languages typically are something called variables. You probably know variables already. It's from algebra. It's when x equals something, x represents that thing. You can think of it as a name, of course. Our names are technically variables of us because we're pretty complex things. But it's kind of convenient, really, just to say, hey, Sean, and just refer to all of Sean, and it's nice and quick. This is how variables look in JavaScript. So the way that you do them is you first you write var, var, short for variable, and then you give a name to that variable. So it could be age, if that's relevant. It could be the name, even, and then you assign to the various things. And so just like basically with variables, when you act on them, you act on what they represent. So just as just a quick sort of sanity check, what would you think age plus 9 is? What is that the equivalent of doing? Anyone can just shout it out. Age plus 9? When I've defined age as 21 plus 9. Yeah. In other words, 30. So basically, if you were to do this within your console, it would just print out 30. And it would just print out 30. Another one here. Tomas, you have something?
What would its output be combining using quotation marks?
Okay, so we'll go over that actually within the hands-on when we add strings and numbers. But yeah. So let's see. Do you guys try this one out? So basically, I'm asking what is name plus comma the sax man, right? So this is different because instead of adding numbers, like we've done for all of our lives, now we're adding these things in quotes, just like words. What does that do? Can anyone tell me? Yeah. Sure. Yeah. Concatenation, a very computer sciencey term for joining things. It basically adds them, right? Whenever you get the result of this, it really turns into Philip Sue, the sax man, because it just adds it all together. Does that make sense? It's just a really convenient way to join these words together. So here's some really common things that you might do that happen all the time. So yeah, when you're joining two strings together, there's a term that I used before defining it. So when you're joining two words together, you can use the plus sign, and then you'll add them together. If you're increasing the value of your variable, say your variable is a number, so say I did somewhere in the code var x equals 0, then if I wanted to increase the value of x, a way I could do that is just do x plus equals 1. So that would change the value of x from 0 to 1. And another way of doing that in shorthand is just doing x plus plus. Did that make sense? Is that good? So like, x is 0, and then I want to add 1 to it. The same if I want to subtract x by 1. So, x minus equals 1 is another way of doing that. Or x minus minus. Both are ways of decreasing x by 1. So these are going to be pretty common. So I want to make sure everyone sort of understands this. Here's a really common mistake that I want to catch before any of you guys run into it and you're sort of confused as to what happens. But what's the difference you think between x plus 1 and x plus equals 1? Where x plus equals 1 is just the thing that I talked about just now. And the key difference really is that sort of one is saved to what x is and the other isn't, right? So x plus equals 1, where x is 0, the value of x, like the actual value that x holds, will turn from 0 to 1. Whereas if you're just doing x plus 1, x doesn't actually change, but you will still get 1. So I hope like that kind of makes sense. But basically, one saves the variable to x, and that's the bottom one. So when you do that syntax, you're actually changing what x holds. Whereas the top one, you're just sort of using x with something else, and using the result of that for something. Question?
Well, not question, but I think what makes that easiest to understand is that x plus equals 1 is shorthand for x equals x plus 1.
That's right. That's right. So the comment was that it should be noted, actually, that what makes this syntax sort of make more sense is that on the bottom, it's really x equals x plus 1. So if you think of it math-wise, like, what is x being assigned to? It's being assigned to itself plus 1. Yeah, good point. Another thing that I want to mention also is that, so I'm going to throw out some terms that you'll learn within computer science. So here they are, defining them now. You all know numbers, so that one's pretty clear. Something you might not have heard is strings. So strings are a different type of value within JavaScript, and basically all programming languages in general. Strings are the ones that we as humans use like all the time. Those are basically words. Anything surrounded by double quotes, or single quotes actually, is a string. And so obviously you can it kind of makes sense why that'd be such an important thing, because basically everything we read is just strings. There's also another type that's neither a string nor a number necessarily. It's a Boolean. And so notice how this value right here, I have true written here, but I don't have quotes around it. Yet it's still sort of recognized by Sublime to be a value. And it's a true or false value is what a Boolean is. So many a times we'll encounter something that has to either go down one branch because something is true or something is false. And the way we sort of distinguish that is we have to have these types that basically mean true and false. Is there a question over there?
Do strings always have quotation marks?
The question is, do strings always have quotation marks? The answer is yes. Yeah, and make sure that they're the same kind of quotation mark too. So you can't start it with a double, end it with a single, or anything like that. All right, so these are the types of things within programming. Like this is sort of the very foundation. Tomas, you had a
What if I put true in the capital case, like T?
Oh yeah, so make sure that you have true the way it's written here. So it won't be lenient to a capital T for true within JavaScript. Because like I said, it's try to be as non-ambiguous as possible. Like this is how it is, just follow it and the computer will understand. So yeah, good question. So this is kind of what I was just talking about. So Booleans, as a review, are those true and false values within programming. And sometimes you want to condition things that happen on the page based on true and false values. So for example, suppose you have a standard web application and you want to distinguish between users who have an account on your application and users who don't. Obviously, users who don't have an account should have a different sort of page that they're greeted with, right? Like they should be like, hey, Facebook is awesome. Facebook allows you to connect with all your friends. Sign up for one. Whereas, obviously, if you have an account and you're a frequent user of this application, it should say, like, here's your news feed. And how does the page know the difference? Well, somewhere out there you've defined this Boolean, this true or false value that says like, is this person who's visiting the page a user or not? If so, show them the newsfeed and everything. If not, show them the sign up for Facebook please pages. So basically, conditionals are sort of a fancy way of how we think all the time anyway. Like, I don't know if any of you have seen Mean Girls, but on Wednesdays we wear pink, right? So, the conditional for that is really kind of simple, and you guys probably do this subconsciously, right? But if the day is Wednesday, then make sure that you're wearing pink is true. Otherwise, make sure it's false. So notice, like, you can basically see the English coming out of this code, right? But in the top, there's like if, so if, and then you have parentheses and within those parentheses, you have a Boolean, a true or false value. And if day is Wednesday, that's either true or false. It's either Wednesday or it's not Wednesday. If it is Wednesday, then of course, wearing pink should be true. Else, wearing pink should be false. Question in the back.
Maybe it's too early for this question, but can we use the name wearing pink outside this conditional? And what about else if?
Okay, so man, we're gonna get to that right now for all of those things. Man, someone better stop messaging me. But yeah, here's a sort of extended conditionals. Like in addition, sometimes there's not just two cases, right? Sometimes it's not just if and whatever is else, right? If something is true, then you also have else if. And what else if is basically it's checking for multiple things. So in this case, I basically did like the Apple product lineup, right? So if it's a phone, it's an iPhone. But another if in there that you can insert is like if it's a tablet, right? Because Apple has like sort of three main products. If it's a tablet, then it's an iPad, et cetera, et cetera. Is there anything confusing about this code that's written here? Anything that doesn't seem to make sense? Yeah.
Do you
Question.
always end with just an else without anything?
So the question is, do you always have to end with an else and something? You technically don't. You actually don't need to have like an else and then stuff inside that body. In fact, if you actually sort of if you follow the logic really, then no matter what's after it, it'll always go to that. But except in certain cases. Oh man. All right. So we have to talk about that. But yeah. Basically, you don't have to have necessarily all of those. You don't have to have like an else case every time. Yeah.
How would it work if you have like 5 different sort of lists?
Sure. So how would this work if you had more conditions? Like you want to catch like if the word is this, or if it's this, or if it's this. Basically, you just have a lot more else ifs, right? You start if with the first one, and then else ifs for every possible case in between. And if it's none of those, then you go to the else case. All right. Or switch. Yeah. Ugh, ugh. That doesn't exist. Just kidding. It does exist, but like, there's going to be a lot of information in this lecture. So, minimize information equals better absorption. Yeah. Question.
You said that there should be a Boolean between parentheses?
That's right. Right. So there should be a Boolean within the parentheses. So in every case here, there is a Boolean within the parentheses. Right. There is a true or false value. Right. So the variable product, in this case, the variable product could be a number of things. It could be phone. If it is phone, then that's a true, right? So it'll enter that case. It could be false. If it's false, then it'll move on to the next case and check if that variable product is instead tablet, right? And if that variable product has the string tablet in it, then true, else false, and it'll just move down like that. So yeah, those are Booleans, and we're actually about to go into like how Booleans can look. Because I know that this doesn't quite look like true and false like how I initially put it. All right, cool. So now we're going to talk about different kinds of Booleans. So I know I said in the beginning like a Boolean is a true or false value, but it's also sort of, you can also think of them as things that evaluate to true and false, or things that pretty much are questions that can be answered with true or false. So here's a really simple question. If you have this particular sort of Boolean expression, where you have some expression x is less than y, what you can basically think of this as is x less than y? If it is, then that's a true thing. If it's not, false. and you can use conditionals to basically move the logic to wherever you want it to move to. But yeah, this is just sort of the very basic one that everyone sort of already intuitively knows. And the same is true with greater than. There's also a true or false sort of value. Here's an interesting one actually. This is equals. Notice how there are two equal signs and not one. Can anyone think of why that would be the case? Can anyone tell me why there would be two equal signs as opposed to just one? Because if x equals y, yeah, question.
Because 1 equals 30 used for assignment.
Yeah. So the answer is that one equal sign is used for assignment, right? So assignment is telling a variable what it should represent. We already use one equal sign for that. So here's what I'm talking about when I say no ambiguity, right? Because if I wanted that also to mean things are equal to each other, I can't use that, right? Because then I might tell the computer you're assigning one to the other, and that's sort of two ways to represent one thing. So instead we make them two distinct things, and everyone understands things. Yeah.
Does 3 do anything?
Yeah. 3 equal signs is an even more particular form of equals, which I don't cover here, but basically it checks not only if the values are the same, but also if the types are the same too. So that's kind of strange to understand. One quick example I can say is that if you had 1, like the number, and 1 in quotes, 2 equal signs would say that's actually true. But 3 would check the type, and obviously one's a number, the other one is a string, the wrong types, false. So yeah, you don't have to know that, by the way, but just saying, for the sake of this lecture, this is how you check if two things are the same. Greater than or equal to. Everyone knows greater than or equal to. Everyone knows less than or equal to. And so, as you might expect, this covers both the equal to case and the less than case. So it'll catch both. Not. Not is, logical not is essentially the flipped thing of what you meant. So not true is false. Not false is true. That's essentially all there is to it. Anytime when you have a Boolean expression that can be true or false, and then you can just not it if you want the opposite. There's also something called logical and. Logical and is represented with 2 ampersands. And it's basically that if you're comparing x and y with logical and there's a logical and in the middle, both x and y have to be true things for the whole thing to be true. So it can't be the case that x is false and y is true, because then the whole thing, when you compare them with and, will overall be false, right? So it's not enough to have just one of them be true. They both have to be true for this to be true. Whereas if you have these two vertical lines, this means logical or, meaning that only one thing has to be true in order for this to be true. Now, it could be the case actually that both x and y are true, and still the thing is it's satisfied, right? Because at least one of them is true. But really, it's just looking for if at least one of x and y, the two things it's comparing with, is true. Does that make sense? This is sort of Boolean logic here that's really, really common. And you're going to be using this a lot within your pages, too, because suppose you're selecting one element, but you also want to say, another element on the page, if I click on that, I also want it to have the same behavior, right? So as opposed to writing 2 functions with the exact same behavior in both of them, the exact same code, you can do or, right? So if I click on element 1, or if I click on element 2, then I want the same code to execute. So that's one way that this is sort of more relevant, because I know right now it might be a bit abstract, but yeah. So this is what it might look like within actual code. So I'm just going to quickly speed up because I sense that I'm running low on time. But basically, here in the if conditional, where the parentheses are, you have where the Boolean should be. And indeed, when you make sense of all of that, that actually does become a true or false value. Is x greater than 10, or is y less than or equal to -2? And you can see that for any given, or for certain values of x and y, that's either true or false. So, can I take any questions at the moment? Yeah.
Were those parentheses around the conditions strictly necessary, or can we just remove the innermost sets of parentheses?
So the innermost sets of parentheses within this example are actually not necessary. I just put them there so it's easier to read. But JavaScript, the way that it'll evaluate it, will sort of already think of it with those parentheses around it. Yeah. Okay. So there's just a couple more concepts here. And like literally you guys are like moving through 61A like really, really fast right now. So I hope things sort of make sense. But another really common thing within programming is something called loops. And it's kind of, when you think about like, when you want to do something over and over again, it's really verbose / redundant to write it that many number of times on the page. It just sort of fills it up. And there has to be some sort of cleaner, more compact way of describing the same thing. And so, lo and behold, they've created loops, which makes a lot of sense. Basically, do some thing of code, some instruction, X number of times. And so here's an example of a loop. Basically, what this one does is that it prints or logs. This is what I is, and then the actual value of I at that point. But just to go over like what the actual syntax means, let's zoom in on just what's new about this. So this is a for loop, is what it's called, and basically, this is how they're written. The first thing that we do is we want to create a variable that's in charge of holding. Basically, it's in charge of holding at what count we are within the loop. So like if I want something to loop 10 times, or if I want the same code to repeat 10 times, this is the first time, this is the second time, third time, and basically it's just very, very computing-like counting where we are until it knows that its value is like 10. When its value is, has hit 10, then we know, oh man, we've already hit the 10th time, we should probably stop. We should definitely stop. So this is exactly what's going on here, really. What we do is within loops is that within the parentheses we instantiate this variable. Instantiate is another word for just create. We create this variable I, the counter variable. And this counter variable starts at 0 because in computer science we always start at 0. Kind of something that I guess I take for granted now. But yeah, it's certainly true that we start at 0. And what this is saying is that while this variable, the value that I has is less than 10, I'm going to increment the value of I by 1 each time. And so every time, like if you imagine that there's code underneath this for loop, basically it'll execute that code, and then it'll increase I by 1. And then it'll execute that code again and increase I by 1. Oh, and every time it checks if I is still less than 10. Right? So it'll be basically everything like 0 through 9, and then when it hits 10, 10 is not less than 10. And when 10 is not less than 10, it's not going to do that loop anymore. It's going to stop executing that code and move on to what's after that for loop. So in this case, that's basically what happens here. It's going to execute that console.log 10 times, and then when the value of I is 10, which is not less than 10, then that's false. And so when that's false, it stops executing this and just moves on to whatever code is below the for loop. Question?
What's the rate that it executes this code? Like, is there like a clock rate for how fast it goes through the for loop?
So the question is there a clock rate about how fast this goes to the for loop? Tomas, would you know this one? I don't know if there's... Sure. Yeah, this is probably Googleable, because this is... I just sort of expect it to work. I'm abstracted away from that. But yeah.
CPU clock cycle.
Okay, it depends on the computer, I guess. CPU clock cycle. Question? Yeah, so there's another type of loop. There's just basically two main types, for and while loop. There are while loops in JavaScript. Am I going over them in these slides? No, to sort of make this more digestible, because everything you can do with a while loop you can do with a for loop, and vice versa. So yeah, those exist. Okay. Yeah.
Actually, there are 4 different types of for loops in JavaScript. There's for in, and while, and do while.
Gotcha.
Yeah.
Okay. All right. Just so you know, clarifications. But yeah. What about this does not make sense? Is anyone still kind of not really getting what this means? basically it's just like, do something some number of times, and we define how long it's going to do them. And we have this counter variable. In this case, it's I that counts to make sure that we're still under that limit at each time. OK. Then in that case, we're going to move on to the very last thing, and perhaps the most sort of intensive thing, and that's functions. So functions, you hear it for the first time, you might think back to math, and you might think back to algebra, really, when you have basically, there's this f of x, right, and it could be something like 3x plus 10. It could be like a line. In JavaScript, and programming in general, there are functions too, and they basically take inputs, and they do, whatever is defined in them, and then they spit out outputs, right? So in this case, here's the function in math and the function in JavaScript. And as you can see, you can pretty much see how everything maps onto one another, right? It's pretty analogous, right? You have 3 times x plus 10, and there's the syntax for multiply and add. I think it's pretty straightforward. But functions in general are just sets of code that perform particular tasks. And so, functions don't necessarily have to take in values. They don't necessarily have to have inputs. So whereas in the previous example, x was the input, is what's given in, it doesn't necessarily have to take in anything. It could be like a 0 input function. But it always has at least one output. Something that may not have been immediately clear is that when you looked at the JavaScript version of the function, you saw this word return. And you're wondering, what does return mean? Is it necessary? Why hasn't he explained it? Return is basically the function outputting and saying, this is my output. And it's basically really important if you expect your function to set an output. But there's a key difference, though, between what I've already said before with console.log. So console.log is actually not a function because it doesn't actually output anything. It actually only just prints things. There's a strange difference, and when you sort of do it within the console, you'll see printing 1 plus 1 looks like the same thing. It's actually doing a function that returns 1 plus 1. But basically, the difference is that you can't sort of manipulate whatever the return value is for something that just prints it, right? Let's see. So if we just look at any function in particular, we can take a look at this really sort of dumb function, but it serves as a good example. It's basically if you wanted to add 2 things. And the way you add 2 things is, of course, your function should take in 2 inputs, right? And so the way we do inputs in JavaScript is that we have, also we call them arguments too. So inputs, arguments, sort of used interchangeably within programming. But basically, it takes in 2 arguments. I can call them whatever I want to, right? So I call them first and second, and I set a variable result, which basically adds up. It basically has the sum of first and second, then I return result. Alternatively, I could also put them all in one line. It could actually be sort of return first plus second. That's totally valid too. But just to sort of show you variable assignment, I've done that here. Yeah. Is there any question about this? So also, in the green too, there's also the name of the function, right? So it doesn't have to be add. It could be add underscore 2 numbers. So long as it's one word, there's no spaces in between, then it's valid. Yeah.
I guess I'm a little confused about return in the context of web design, web development. When would you ever want things to be printed out? I would think that you want your function to change some CSS or change some HTML or something like that. So when would you ever want things to be returned?
Right. That's an interesting question. So when would you actually want things to be returned within web design? Really, it's like when you start playing around with the more advanced sort of frameworks. So typically, one that I'd highly recommend for everyone after this course is one called AngularJS. I think it's a really smart framework, and that's when you start to return whole pages. And it's kind of weird to think of it like that, but basically you return sort of something called controllers, which basically are sort of modules within the page. And if you wanted to return those things, you'd use return. But yeah, it's an like I said, this particular lecture is more of like a sort of diversion, programming in general, and then we're going to go back to jQuery once everyone's sort of comfortable with programming. Yeah. Tomas?
Yes, there's one thing I said wrong that I want to clarify. Sarah, she told me that there's two more types of loops, for each and for in.
Didn't you say this? Okay. All right. Interesting. Obscurities. I'm not too big a fan necessarily. I think that if you can use, standard for loop, which is pretty much all you need 99.9% of the time, that's all you gotta, keep in your head. You only have so much space in there, and knowing this is just taking up space. But anyway, so just, we define this function here. So the first part up here is defining the function. Like, this is what happens when you define it. But that doesn't necessarily mean we've used it yet, right? We actually haven't really added anything yet using our add function. And so the way we actually use the function that we made is we call it, right? And so if you look at the bottom there, I have a function call. And what I've basically done is I've put in two values for the inputs, two arguments, right? And those numbers are 8 and 5, right? And basically I expect to add 8 and 5 and have it return the sum of 8 and 5. And that's how I use this function. So there's function defining, so we define the function at the top, and there's calling functions, and that's at the bottom. So just if you ever wondered, like, how do I actually use it? That's how you actually use it. Okay, let's see. Here's a quick common mistake that people make, so I'm going to catch it before you make it. Something that's kind of interesting within functions is that you have to make sure that you don't mess around with the names of the inputs that you've given within defining the function. So, for example, here's a function called foo, and its one argument or input is called bar. And suppose within the function, every time when you call it, basically what it's doing is it reassigns bar to the value 1 and then returns bar, essentially returning 1 every time. So no matter what you put in this function, whether it be like 10, 15, whatever number, or even a string or a Boolean, whatever like you call this function with, it's always going to return 1. And that might not necessarily be what you want, because a function that always returns 1 or the same thing is really not necessarily useful. Question?
Yeah. So let's say I set bar to like 5, right?
Mm-hmm.
All this as returns 1. If I go to the next line and I say print bar, will print like 1 or will print 5, like outside the function?
Ah, okay. Now we're talking about scope and what bar is outside of the function. So here's a strange thing that might confuse people that I don't think. Bar doesn't exist outside of the function necessarily. Like unless you have a variable called bar outside of the function, it will say like what is bar, because it won't really know. Basically, within functions, I take the name of this input, and within the function, I do stuff with it. And then right when I return it, I'm outside the function body. I'm outside of the function definition body, and then it just doesn't exist. So it won't know what you're talking about. It'll say bar is undefined.
Or like if like I call it on like a variable or I assign outside of it,
Mhm.
will change that.
Ah, okay. So yeah, this is definitely good to know. But like, if you call this and you expect bar to be reassigned to 1 outside of this function, the answer is that it won't. But I don't think that kind of knowledge is necessary for web design purposes. But yeah, like scope is like something that confuses like 90% of 6UNA students, and it causes a lot of them to drop the course. But really, like, I don't want to go into like it's strange because I don't want to go into like super detailed. I just want you to know what functions look like, the fact that they're called functions, and don't make this silly mistake when you're defining functions. These are sort of just all I really want you to know and all you really need to know, in case this is like totally your first time ever messing with a real programming language. So yeah, always overwritten. I believe I've reached my my point where I should stop, but I'd like to answer like any questions or any confusions you guys have about anything I've said. if there's anything, basically we went over, we went over like basic syntax, like there are things called variables, which are really useful, because sometimes you don't want to like use the same value over and over. You just want something that represents that value. We also went over conditionals, right? And when you think conditionals, you think if something, then do something else, right? That's all conditionals are. Now you know how to loop things. So we also went over how to do something X number of times. So you don't have to actually write it X times. And most importantly, we also went over like functions, which are like sort of the paradigm within JavaScript programming. It's like everything revolves around functions, using them, passing them around, et cetera, et cetera. Question?
When we write in JavaScript code, where do you save it to? Does it go into the file?
Okay. Oh, wow, that's a really foundational question. So where do we write JavaScript code? So just like within CSS files, you actually create like a script.js file or whatever .js file, and that's where you write your JavaScript code. And then you save it, and then like in the very beginning, we showed you how to link it, right? So you just link the path to that. Question?
You can also like do it inside the HTML file, right?
That's right, yeah. So there's inline JavaScript, not recommended, harder to read, better to just sort of put it outside. Question?
Are any of these variables going to refer to things within your HTML file?
Are any of these variables going to refer to anything within your HTML file? Yes. Yes, they can. So they can refer to, you can actually store elements of the page within variables. And that's actually like somewhat common. And we'll definitely talk a lot more about this with jQuery, which makes that a lot more clear. Okay. All right. I hope everyone is understanding, maybe mind blown. But yeah, that's JavaScript. Next week we'll talk about jQuery, which is a library written in JavaScript. It's basically JavaScript, but it's put in a way that's way more intuitive for doing front-end web stuff. So now I think, yeah. What?
I don't know this too in-depth. I don't know if you'll explain it during jQuery, but the DOM, can you explain that?
Oh, sure. Yeah. Ooh. Okay. So yeah, the DOM is basically an acronym for Document Object Model, and it's basically the sort of paradigm that everything on the page is an object. Every element on the page is an object, and those can be sort of passed around and manipulated. There's probably a lot more intricacies to that, but yeah, typically people, when they say manipulating the DOM, they mean like doing sort of animations and manipulations and things like that. But yeah, I probably won't use that terminology because that's more than enough then terminology for one course. But yeah, is there anything I'm missing about? Okay, so this week is a little different because we have like a super long hands-on and no design hands-on. It's just going to be one that's just going to challenge you to think in terms of JavaScript. So yeah, Philip and Sarah will be doing that right now. Okay, Philip told me. Yes.
Okay. Oh wait. This is.
Okay, hi everyone. It's Philip and Sarah. So we took a lot of your survey responses to heart, and we're actually planning to combine our hands-on for this week, especially since JavaScript is such an important topic. So for the first 10 minutes, we're just going to be talking about the sort of basics of like what are variables, what are the different types, increments and decrements. And then in the second half, we're going to be talking about functions and while loops, conditionals, that sort of thing. Okay, so to start off, this is a hands-on, so it'd be great if you all followed along. And you can do that by just opening up Chrome and clicking on the web inspector. And if you go to the console tab, then you can follow along with everything we're doing. Okay, so yeah. So Phil's going to start us off by talking about increments.
All right, thank you, Sarah. Yeah, so if we go too fast, just let us know. I know a lot of you guys said that the hands-on, especially for programming, goes a little fast. All right, so the first thing we're gonna learn is incrementing a variable. So as Andy mentioned, the syntax for declaring a variable is to say var, and then I, and then you can assign it a value. So if we assign it a value of 0, so now this letter I contains the value 0. And we can check its value by just typing I and then entering, and you guys see that 0. I can make it bigger, yes. Okay. Now, the next thing that, so Andy already mentioned this, but he went by a little quickly, so we'll just do it again. So if I do I plus 1, right, and I click enter, so you guys see that I get a value of 1. But the value of I is still 0 because we haven't assigned it anything. So we said, okay, I plus 1, that value is 1, but we didn't say that we're going to store that value back into I. So if we actually wanted to change I, we would have to do I equals I plus 1. Does that make sense to everyone? So we can check, and it's still 1. Is everyone good? Yeah? All right. And I'll just clear the screen. Sarah will explain what that does later. So a shorter way to do it, it's just sometimes computer scientists are really lazy. As an IUR major, I would understand. But yeah, a lot of people are really lazy, so they came up with this like shorthand syntax that's like I plus equals 1. Right, so let's check. I right now is 1. So if we do I plus equals 1, we get 2. And let's just check that I did indeed change to 2. So you guys basically see two ways of changing the value of I. Basically, I equals I plus 1 and I plus equals 1. Are there any questions so far? We're going really slowly. Yeah? Yeah. Yeah, so it's JavaScript requires you to use, yeah, see like right here, this line, and this line is me being really bad and not following good syntax rules or style rules. You should have a semicolon after like every line, or every statement, yeah. It lets, like in this case, it lets the console know, oh, this is the end of the statement, yeah. Okay, so are there any questions? Okay, same thing with decrementing, it's essentially the same thing. So right now, the value of I is 2, right? So if we do I minus 1, and it shows us that it outputs 1, but I is still 2. So if we actually wanted to change the value, we would do I equals I minus 1. And then if we check, I is 1. And let's just play with the shorthand or the shortcut way of doing it, which is I minus equal 1. And then we check I is 0. Any questions? All right. So now I'll talk about, we'll play around with types. As Andy mentioned, there's 3 types. There's numbers, there's strings, which are like letters, and then there's Booleans. So var, let's say var best TA equals Thomas. Yeah, Thomas. Not Tomas, but Thomas. So let's check. Best TA, the value is stored as Thomas. All right? So the cool thing is, you can do the plus operator. As someone mentioned, it's concatenating. You can do this, like pretend they're integers and do the same thing. And if you just do plus like the grade, it'll output what you want, but best TA has not changed. So since you guys are pretty smart, we'll just go straight to the short notation. And we can do this. Great. And now best TA stores the value Thomas the Great. Yeah.
Do a best TA dot replace H.
No, no, no.
comma,
All right, so Sarah's going to talk about this idea, or like that you can you can reassign variables. Are there any questions so far? Yeah? No? Good. All right.
Okay. Okay. So we all know that Thomas is not the best TA. It's actually Tomas, right? So I'm going to do a reassignment. So basically, I can override whatever value my variable previously held. And in this case, I'm going to change Thomas to Tomas. Okay, so now best TA is Tomas. And let's keep playing around with types. And let's try to see what would happen if we joined a string with a number. So this is actually a question that Tomas asked earlier, and we are answering it, doing the hands-on. Okay, so if I do best TA plus equal the plus 3, or plus RD, what do you guys think will happen? What will best TA become? Yes, it'll become Tomas the third. And then we can just check that best TA is indeed Tomas the third. Okay.
Sarah, you forgot a semicolon there. That's bad style.
Okay. So generally, when you add, when you have a plus operator between a string and a number, we're actually going to convert the integer or that number into a string, and then just do a regular string concatenation to just join the strings together. And the exact same thing is true for booleans. So let's say that I define a boolean var x equals true, and booleans are again just things that can hold two values, true or false. And so if I concatenate that with best TA, then what do you guys think will happen? What will result? Don't be shy. It's more awkward for me.
Sean, what do you think? Oh, yeah, sure, go ahead.
No, 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 no. Oh, no, 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 no. We don't care about that, Sean.
We're adding true to the end of your string.
Mm-hmm. Yeah, that's exactly right. So we have Tomas the third true. Cool. Are there any questions so far about this? No? Oh, yeah, in the back? Yes, it did. Mm-hmm. Okay.
All right. So now we'll talk about. So Andy also mentioned the console and alerts. So now instead of using this, we'll go into JS Fiddle. So you guys have seen JS Fiddle before. We've used JS Fiddle to show you guys just like little snippets of code with HTML and CSS. So you guys can see like it says HTML up here and CSS up here. Can you guys see that? Here, let me make it bigger. Well, basically, this is for HTML. So it's like HTML. And then this is your CSS. And over here is a JavaScript. And we've never used it, but starting from today, you guys will start using it if you guys want to test stuff. So as Andy mentioned, there's alerts. There are alerts and consoles. So just to give you guys a quick idea, let's do an alert and just say like hello world and end with a semicolon. So just to test it, if we run it, what we should see is an actual alert pop up with the message hello world. And if we run it, we see, yeah, you guys see it? It says hello world. Yeah, I'll make it bigger. Yeah, so if I run it, I get this, oh, I can't make this bigger, but it says hello world. And then Andy also said that you would use console.log for kind of like debugging stuff. Because when you have like a lot of code, you don't know exactly what this variable says, so you just want to like print it out and check. So you can do console.log hello world. And then if you run it, and then you right click and inspect element, and you go to console. That's from what I typed in the JavaScript, JS Fiddle. Does anyone have any questions? Okay. So it's also really good style if you have a lot of code, like a long piece of code that you kind of put comments throughout. And there's two types of comments. There's single line comments or inline comments and also multi-line comments. So like for example, if I have like this function that does console.log hello world and I just said, I can do a double / and I can just say like this function does logs hello world. Okay, and sometimes like my comments span like 2 lines, and what I want to do is have multi-line. I could do like two of these, like 2 single line comments, or I could do this. It's a / and then star, and then /. So anything between these two guys will be commented out. And it's really good. It's just good style, especially if you're working in groups and stuff, to kind of like document your code, let everyone know what's going on, so that if someone who's unfamiliar with your code reads it, they can like see it easily. And one final thing before we go on our break is that, so we were on the console and like things get really long. Let's say like var I equals 0, and then you just keep printing I. Okay, and then like we want to clear it. Like we want to start from the top again, have like a fresh page. We can just do clear like that, and then it clears it so that it's more, so that you can like kind of see where you are right now instead of seeing like the history of everything you've done. Question?
Should I write a comment for each line of code that I write?
Generally, probably not. I would usually write comments for each function because you generally have a lot of functions, and some like just naming the function might not be enough to kind of explain what the entire function does. So you put a comment on top of it saying like, oh, what does this function do? So when someone else reads it, they can kind of figure out. Or else they have to like run through the code, like run through the logic in order to figure it out. Yeah.
I have something that's being printed with console continuously. Is there a way I can like fix the information or something like that? That's an issue.
Yeah, so if you like write your for loop incorrectly or something and it keeps going on forever, I think you just like close the console or something and it'll break. It'll just stop it. Yeah, we'll let you know after. But usually if you like right click and then you see that it keeps printing, you know that your logic is wrong. So you go into your JavaScript and fix it up. We'll test it out and get back to you after a while because we haven't practiced for loops yet. So, but we'll definitely do that after the break. Any other questions? Okay, so right now we'll take a 10-minute break, and then afterwards we'll finish part 2 of our hands-on, which is going to be about 30 minutes. And yeah, so see you guys in 10 minutes. Close this.
Sean wants us to take this.
I think the pace is really good. You guys should continue.
wants more time to talk, and that means we have less time to present. Wait, 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 wait. Okay. Oh, so someone earlier asked basically how to quit an infinite loop in console. I actually couldn't find a way to do it in console, but if you load a script, then you can actually like pause, step in, out, use it just like a debugger, like GDB or whatever. So yeah, for whoever asked that, check this doc if you're interested. Okay, let's go back to the course material. So let's quickly cover if-else statements again. Okay, so as Andy talked about in the lecture, the if-else statement looks like if condition, or condition. We do something, else we do something else. Okay. Yeah, so that's what an if-else statement would look like. So a long-term dream of Sean's has been to walk into a crowded room and scream, "What's my name?" And the crowd would go like, "Sean Park, Sean Park." And so today we want to make that somewhat a reality. So I even made this sign for him, except it says Sean Parker because I like to deny dreams. But okay, so let's try to apply this. So let's have a variable called Sean's ego. And we'll set it to true. So if Sean has an ego, then he's going to alert and be like, "What's my name?" Otherwise, he's just going to act like normal and just be like, okay. So, oops. So what do you guys think will happen when I run this code? Yeah, exactly. An alert will pop up that says, "What's my name?" And indeed it does. Okay, cool. So what would happen if I change this to false? Yeah, pops up. Cool. So another thing that we can do is basically invert the ordering of this, right? So right now we have the condition that being true, executing this first statement, but we can actually reverse this by just adding a not here. So this exclamation point is the logical not operator. And if we add this, then we can switch the location of the two alerts. So what's going to happen looks exactly the same. So let me comment out this code. If I run this again, I still get because Sean's ego or not Sean's ego is true, because Sean's ego is false. So not of Sean's ego is true. So I'm going to return this alert of Okay, cool.
All right, so as with a lot of things in computer science, you can nest things. And so we're going to show you guys nesting if-else statements. So let's define another variable called shy students. And you guys seem pretty shy today because you guys aren't answering my questions. So that'll be true. So let's change this back to what it was originally. Yes?
Can you do camel case, please?
Okay. Yes, sir. Okay, so now we can say like, so Sean's going to try to elicit a response from the students. And if shy students, then they will alert or like kind of give like an awkward silence. And then else, they will amuse Sean and yell Sean Park. So yeah, like the point of this exercise is that you can nest if-else statements. So if we kind of run through it, the flow is like it'll check is Sean's ego true, and it is true. And then it will check, so it'll run this conditional, and then it'll go line by line. It'll alert what's my name. So you'll see an alert pop up, and then it'll go to the next line. It'll check if shy students. So in this case, shy students is true. So it'll run this alert. And then once it reaches the end of the if statement, it'll just disregard the else because it already ran one of the conditions. And then it keeps going and it sees this else, but it already ran this if, so it'll disregard this. So theoretically, you guys would see two alert dialogues. One is what's my name, and then the next one is awkward silence. Are there any questions? We'll test it out, but are there any questions? Okay, so let's run it. We get what's my name, and then awkward silence. All right. Sarah's gonna show you guys, like, you guys can kind of simplify these nested if-else statements because they look kind of messy right now with this thing called conditionals.
Yeah. So as Andy talked about, there's also something called the else if, which is basically if we want to try more than one condition. So I'm going to convert this code up here into an equivalent if, else if, and else statement. Okay. So if Sean's ego and shy students. So this is again the logical and. It basically just makes sure that both of these booleans return or evaluate to true or are true before it executes. Okay, so I will copy paste this and also copy the awkward silence. Okay. The other condition we need to check for, we'll add with an else if. So here we have Sean's ego and not shy students. Let me see if I can pull this over more. Okay. In this case, Sean will continue to say, what's my name? And this time, y'all will oblige and say, Sean Park. So there's one condition left. And that's, or basically there's two possibilities, right? That Sean doesn't have an ego and that you all are still shy, or that Sean doesn't have an ego and you all are not shy. But either way, we can catch those with this one alert message, because if Sean never says what's my name, then you guys will never say Sean Park. So this else is basically a catch-all, and these are hopefully equivalent statements. So let me remove this, and let's try running it. So we have first what's my name, and then awkward silence. So this is with else if and with logical ands. Okay, and now Phil's going to talk about functions.
All right, so functions are probably one of the things you guys will use a lot in JavaScript. So we're going to delete all of that. Now we're going to talk about functions. So first of all, function with no arguments. So Andy mentioned that there's two types of functions, functions with arguments and functions without arguments. So an example is function. It's a reserved word in JavaScript. So when you say function, it knows that, okay, you're about to like define a function. Let's call it greet. And then inside we'll just go like console.log hello. All right. And then just having this, nothing is going to come up because we didn't actually call the function. We only defined it. So if we actually want to see results in the console, we would have to have function calls. And so what we would do, we would call greet, and now we would have, in our console.log, we would see it. So I just ran it, and we checked our inspector. Do you guys see it says hello? So greet was called, and it printed hello. Any questions? Great. All right. Now let's see a function with a parameter. Let's greet person, and then it'll take a variable called, let's call it name. So, and then it'll do hello, and let's use a concatenation operator, and we'll do plus name. So, and what you would do in this case, instead of, you would have greet name, and let's say we wanted to greet, greet person, and let's say we wanted to greet Sarah. So if we kind of follow this, when you call greet person, it looks for the function greet person, and it sees that you fed in this value called a string called Sarah. So any instance of, or name is assigned to Sarah, and inside the function, any instance of name will be replaced with Sarah. So what you guys will see is like a, I'll just show you guys. So if we run it, we inspect the element, and you guys can see that it says, hello, Sarah. The first one was from the previous iteration of greet. Are there any questions? Yeah, no. Okay. What? Okay. Yeah, so that's basically like the basics of everything. Here.
Yeah, so we're going to have to cut our hands-on short, but it's also uploaded on the website, and I highly encourage you to work through the example of building your own calculator. So Andy showed you how to do the add function, but you're going to be implementing sub, multiply, and division. And eventually we'll be using a for loop to implement multiply using just a bunch of additions. So I encourage you to check that out. And Sean's going to do his lecture now. Okay.
Thank you.
Hi guys, what's my name? Alright, I guess John's ego was true and you're not shy. Thank you for making my dream come true. I'm just kidding. This week's lecture would be user experience. So you guys just went through a lot of the design aesthetical parts of this class. But this class is not a graphic design course. This is not an art class. This is a user interface design. So it is very important that we cover the other side of the equation, which is user experience. Due to time constraints, I'm going to leave all of the announcements and logistical stuff to the email that we're going to send out later this week. And user experience, it's UI, user interface, it's more than just aesthetics. You have taken into account, the big picture is the interaction that the user goes through when the user is using your application. So it's not just how the colors behind the buttons, it's about how that color gives emphasis to that button. And that's what really makes user interface design different from graphic design or any other art form, because user interface design is meant to improve the usability of an application, not just create a beautiful interface. So this week, I'm going to give you 8 tips for a great user experience. So number one, I have to really touch upon this because after seeing your group project, some of them are really good, but a lot of you lost points just because you guys didn't have enough consistency throughout your design. Consistency is extremely important because if a user visits your website and sees that all of your pages look like it's designed by different people, then they're going to be thrown off, and it lacks a consistent user experience for that application. For example, if the navigation bar is a top bar on one page and a sidebar on the other page, users will have an expectation when the user first visits an application that navigation will be on the top, but then because it's now on the sidebar, they're going to be lost. So you should have a consistent placement of modules. If you're going to have a top bar, stick with a top bar. If you choose a green as your main theme color, stick with the green. One thing that's really struck out to me during the group project was that some of you had a light color for one page, and a dark color for the other theme. If you choose one color scheme, especially light and dark, you should stick to that one theme. Another thing is fonts. Don't use more than 2 fonts. And if you're going to go all out flat design, stick with flat design. Don't do one page flat design, the other skeuomorphism, and so on and so forth. Again, I think the best example of this is Google. Google is one of the biggest IT companies in the world, but they have a very consistent design all over their application, from Gmail to Google Drive to YouTube. So consistency is extremely important. Any questions regarding consistency? So the first three would be kind of like a little bit of a re-emphasis, a reiteration of the previous design topics that I've talked about. Emphasis is really important. I think that in a good user interface, there should be a difference between important elements and not important elements. And your goal as a UI designer is to order your features by priority. And you can give emphasis by positioning, spacing, typography, and color. So you have to first start off, to accomplish this emphasis, you have to start off with the purpose of an application. One app that we could start off is asking what's the purpose of Piazza, for example. You guys have all used Piazza for this class and maybe some other classes. Maybe this is a question for you guys. What is the purpose of Piazza? Any thoughts? Yeah. To get your questions answered. That is number one purpose. What would be any other purpose of Piazza? Yeah. Yeah. So for instructors, Piazza is a good place for you to give out announcements. So if I were to order the features of Piazza by importance, I could say number one is question and answers. So it would be number one. The most important thing should be list of questions. By the way, Lorem Ipsum word is going around. Number two would be you want to read questions, and you also want to ask questions. So it would be adding a new post. And number three would be, because you want to find questions too, you want to search for questions for topics. And you also want to navigate to another class, and you want to add a new class. So these 5 things would be the most important features for Piazza. So what I did as a quick side project last week was I did a quick redesign of Piazza for fun. And the first thing I did was to really reorder the application by a list of emphasis, a list of priorities. And as we see in this list of features, the number one thing that's important is the list of questions. So I gave as much space as possible for the list of questions. And then the second thing that's most important is new post. So I put the new post button on the bottom right. And if you guys recall from the F-style layout, bottom right gets the least amount of emphasis. Can anyone tell me why I chose to put the new post on the bottom right instead of the usual F-style layout of top left? Why bottom right? Any thoughts? Yeah.
You have the user actually look for the answer before they put the question.
That's one thought process. Yeah, that's really good. So users might want to look through the questions first and then get to, if there's no answers, then get to the new post. Any other thoughts? Yeah.
Kind of out of the way and can be on every page.
Yeah, that's a very good point too. By placing the new post on the bottom right, it really gets out of the way of the users when they're reading the post. Any other thoughts? Yeah. Yeah. So for I think those 2 points make sense too. I think it's really, really cool. My thought process behind this was, when you're using a phone, I think that the reachability of from your thumb is very, very important. So if I were to new post, if it's on top right or top left, I have to reach all the way to over here. But if I put it on the bottom right, it's really accessible. So that's why I put it on the bottom right. Yeah.
One more thing I think too, because the keyboard is down, so you wanna write a
Oh.
post to use the keyboard.
That's a very interesting point. Because the keyboard is on the bottom, after you press the new post, your thumb is likely to go to the bottom of your screen anyways. So in terms, again, reachability from your thumb, that's a very good point too. So this is how I really order the emphasis of Piazza a little bit. Again, the third would be the search. It's on the top right. And classes, choosing a class, it's hidden. So if you click on the menu icon, the title bar, it shows you the sidebar that shows your classes, and you can add a new class from there. And because it's hidden by default, hidden elements have the least amount of priority. So adding a new class has the least amount of priority, but it's always accessible as long as you press the menu button. Yeah.
Why did you opt to use this hidden sidebar? Why not do different classes on the bottom of your application?
Yeah, that's a very good point. So Kevin asked, why did I choose to use a sidebar instead of the iOS style, the bottom navigation bar or the top bar? So one reason which I'm going to mention in the next point, which is hierarchy. Number 2 is that Piazza has a list of classes. And what if you have 10 classes? it's going to be really like you cannot place 10 classes on the bottom bars like right next to each other. That's why for like lists, it lends itself to a vertical view. For that, sidebar is better. But for the second point, the hierarchy, I'm going to get to in a bit. Okay. So how many of you have heard of what's called a sitemap? Yeah, can anyone tell me what sitemap is? Any thoughts? Yeah.
It's like an organization of every possible place you get to the website, so that you get a bunch of links to every useful page.
Yeah. So
Yeah, show the organization.
So yeah, just like Sean said, sitemap is an organization of all the pages that you can visit from a website. So for example, for Piazza, their sitemap would be you have Piazza, the app, and then on the bottom of Piazza, you can go to classes, Piazza careers, and account settings. And within each classes, like web design DeCal, for example, you can go to Q&A, class information, and you can add a new post. Each website has these sitemaps. All of the website is organized in this hierarchical fashion. So for your website, it is very important for you to create a sitemap and to organize your website and make your user interface based on that sitemap. Piazza has a very big problem with the hierarchy. If you look at their mobile app, in the sidebar, all of their the list of items in the sidebar, they are not all in the same hierarchy, but they're all on the same level. For example, CS98, 198, the class is not on the same level as Q&A and course page, but they're on the same level in the sidebar. Account settings is one step above Q&A and course page, but it's right next to the Q&A and course page in the sidebar. Same thing with the bug reports and logout and my profile. So what I did to clean up the hierarchy a bit is that everything in the sidebar should be all the features relevant to Piazza on a global application level. So that is, on a global application level, you can add a class, you can go to other classes, and you can go to settings, your profile, or sign out. But everything that's inside that specific class, like question and answers, class information, and so on, that's inside, those are inside the main view. So that would be this view, for example. So search, class information, adding a new post, everything that's specific to this class is inside this view, and everything that's specific to the application is on the sidebar. So that is another reason why I chose the sidebar. Due to time constraints, I'm going to just roughly skim through the design exercise and skip through it. And if you have time, you guys should really think about how do you improve the hierarchy of Craigslist, for example. Craigslist has, I'm pretty sure if you were to draw out a sitemap of Craigslist, it would be very different from what you have right here. So if you have time, maybe take time to kind of improve the hierarchy of Craigslist too. Another thing that's really important is call to action. For each page that a user visits, there should be, you have to think about what is one action that you want as a site maker to take when they visit your website. And this element should receive the most amount of emphasis. And when you're designing a landing page for your startups or for your promotion page or whatever, you should start with a call to action, and you should end with a call to action. A good example of a website is called Mapbox. Let me show you the website. Mapbox.com. It's basically I don't quite know what the app is. I just find this user interface beautiful. But it starts with a call to action. Their call to action is try it for free. This button is what the makers want you to click on when you visit the website. And as you scroll down, if you're not yet convinced to try it for free, it asks you to read more about the app a little bit more. So there's a read on, and they end the page with another call to action. Start now. Are you convinced yet? So if you're convinced, then start now. So when you're designing the landing page, or if you're making a portfolio website, for example, you might want to start with a call to action, maybe like email me or get in contact. And then you want to end your portfolio page with email me again. Okay. That's my trying to find. So throughout this lecture, I'm going to give you some examples of how you can improve the call to action a little bit through some code examples. You don't have to understand how this works right now, but just to give you some thoughts as to inspiration as to how you can utilize this. There's this thing called CSS active pseudo class. Let me give you an example. So here I have list of items, and one really good rule of thumb, it's really documented in Google Material Design too, is you want to give users feedback when the user clicks on a button. So that may be in a change in the color or increase the size and so on and so forth. So for here, what I did was, if I click on it, it expands. I'm not sure if you can. Let me just change the background a little bit to make it clear. So now if I click on it, it becomes bigger. So this would be a good user feedback. To implement this, what you can do is there's this thing called active pseudo class. I'm pretty sure you guys have used the hover pseudo class a lot in your group projects. It's a similar thing. So if there's a CSS rule that says item active, and what this will only execute, this line of code will only execute when the user clicks and holds on to an element, or that split second that the user clicks on an element. And when the user clicks on it, it's going to scale. I'm going to talk about this in 2 weeks. It's going to scale, that is like expand by 4%. Yeah. Yeah. So only that box, right?
Yeah, how do you transfer just that box using that overall class?
So that works because if I click on this element, only one element is being clicked. Not all elements being clicked. So it works similar way to the hover. So when you hover over this element, only the element that's hovered over gets triggered with that class, not all the elements, because not all the elements are being hovered. Same thing with active. Okay. So I think I'm going to mention this in a bit in 2 weeks when I do the 3D animations lecture. WebKit transform does not affect the layout of the page. So one thing that's, because you guys are learning JavaScript, I really have to mention this. You have to design your website for performance. It's at first, when you're first learning JavaScript, you might think the animations are so cool and all. But if you like overload the website with animations, it's going to slow down your website immensely. Especially CSS animations are not that taxing for your computer, but JavaScript animations and JavaScript calculations, they're very, very taxing on your computer. And especially because JavaScript runs on your computer, on your web browser, it depends on how powerful your computer is too. So if let's say I'm making a website, I'm testing on my MacBook Pro Retina, it might work, but if I test it on my mom's computer, which is like 2006 HP, it might lag like crazy. So it is very important that you really want to use animations only when you have to use it. Also, you have to test on all browsers. As a rule of thumb, Chrome and Safari has the fastest JavaScript performance, and then there's Mozilla Firefox, then there's Internet Explorer. So you always want to test your scripts and animations on all browsers and as many devices as possible. It might run fast on your computer, but if you test it on your phone or tablets, it might lag because phones and tablets have slower processors than your computer. What's also important is this thing called CSS transforms. I'm going to mention this in 2 weeks when I do 3D animations. This is one of my areas of biggest curiosity. What CSS transform does is, maybe like I should mention, when you do your CSS transitions or JavaScript transitions, usually what happens is your web browser calculates everything and it just makes it for you. So it only uses your CPU and it only uses your computer, like the web. Your performance is based solely on the web browser. It does not use your graphic card. What CSS transform does is CSS transform will use your graphic card to enhance the performance, so and so called hardware acceleration. And one of the reasons why a lot of native applications, if you look at mobile apps, for example, Facebook native app is a lot faster than Facebook mobile web app because native apps have access to a computer's graphic card, which makes the animations a lot smoother. Usually, it's not possible on web apps, but with CSS transforms, you can make your animations a lot smoother. So let me give you an example of that in practice. I'm going to do a transform example. Actually, I think I have it open. So here we have a gallery of images. This is a regular CSS transition. So if I click on this, it's going to slide. But I'm not sure if you can see from the projector, but it's a little bit stuttery. Let me click on slide. It's a little bit slow, and it feels a little bit clunky. Whereas if I use the carousel transform, here I'm going to use a CSS transform. I'm going to click on this. It's a lot snappy, a lot more snappy than the regular transition. So the only difference that I made is that in the transform example, for the CSS, I used the WebKit transform translate X, which I'm going to talk about this in 2 weeks. If you use this would be a lot faster. Translate X versus if using the regular margin left. Here I use a regular CSS property. If you use a regular CSS property, it's going to run slowly because it doesn't use your graphic card. Whereas if you use the transforms, it uses your graphic card, so your performance would be equivalent to that of native applications. This is why I think in the future, someday I think web apps might possibly take over native apps just because the performance is it's improving year by year. So more on CSS transforms, how cool CSS transforms is during the 3D animations lecture on November 18th. Any questions regarding animations and performance? Yeah. You should use transforms when you're using the animations. If you're performing an animation, you should try to use transforms over regular CSS properties, only for animations. Okay. Yeah, it's not necessarily really old computer, really old web browsers. Most of the cases, WebKit transforms will work for all Chrome browsers because Chromes are updated automatically. Safari too, Firefox too. Internet Explorer, I'm not too sure. Yeah. One thing that's really important is cost of action. Cost of action is each action the user needs to make in order to accomplish a task. This is really critical for signups. Let's say you have a startup. As a startup, you want to onboard as many users as possible, and you want to make sure that your users perform the right action that you want the users to make. For example, if you're running a blog startup, you want your users to sign up for a service and make a blog post. So how are you going to minimize that cost of action? You have to really worry about different kinds of cost actions first. There are many different actions. Number one is scroll, number two is hover, and number three is click. And all three of these command different amount of cost of action. Scroll is least costly because all the user has to do is just scroll through, and especially for Macs, the scrolling behavior is very, very natural, so it doesn't require almost any cost. Hover, the user does not even have to exert a force. You can just place your pointer over it, and it's gonna just work. And click is the most costly because the user must first move your pointer to that button and actually click on it, actually exert a force. And as trivial as it sounds, a lot of people are lazy, and this really makes a difference when it comes to designing a good user experience. So what you want to do is, when you're creating a registration flow, you want to minimize the steps the users want to take when they sign up for a service. Tumblr, for example, only requires you to enter 3 information: your email, password, and username. And I don't even think you even need a username, but for Tumblr, it's a blogging service. They kind of ask you to create a username. And after you enter these 3 things, all you need to do is click one time, and your account is already set up, except for the signing up privacy policy stuff. Another thing that's really, another good example of a cost of action is called infinite scroll. I think you guys have encountered this when you use Facebook. When you use Facebook, when you reach the end of the post, without having to click on next page or whatever, it automatically loads up new posts. And this sort of behavior is called infinite scroll. It really gets rid of a user the cost of clicking on a button to go to the next page. So let me show you a demo of that. I already have it open. This is blocks. So in the regular example, let's say I have a list of blocks. I reach the bottom of the page, and I have to click on it to load more. Click, load more, click, load more. There's this like lapse in user experience. All the user wants to do when the user is on this page is to read through the blocks of content, not necessarily worry about continuously loading new content. So what infinite scroll does is, if I reach the bottom of the page, it loads more content. So I can just go on and on and on as it loads. So you can achieve this effect using a few JavaScript. I'm not going to go into detail how you achieve it. Maybe we can mention this in the later lectures. I can give you some code snippets. Just give you an idea. There's this thing called there's this jQuery plugin called Waypoint. You guys should look into this. Waypoint, W-A-Y-P-O-I-N-T. And this jQuery plugin allows you to achieve this effect. So I highly encourage you to check this out. So design for failure. This is another very important point. As a user experience designer, you have to really treat your users like a 7-year-old baby. You have to think about each possible cases of mistakes that the user might make. These might be like cancel button for forums, going back to the list after viewing an item, or a closing button for a motor box. Just to give you an example, there's this thing called motor box. Motor box is it's like a dialog that pops up when the user only if the user requested. It's hidden by default, but when the user clicks on some button, the box shows up. So it'll be something like this. For Twitter, there's a new post button. The new post is hidden by default, but when you click on it, it shows a composed new tweet box. And what if the user wants to go back? You could say that they could just click on one of the black areas, but some people who are new to Twitter might not know that. So that's why for their motor box, they have this tiny X icon on the top right of the motor box. You have to really think about each possible cases for the user. You have to really think about the user as if they're 7-year-old babies. Content editable is a really important topic, but this is a little bit kind of advanced topic too, because so due to time constraint, I'm going to really skim over it. It's basically a edit box. Let's say I make the Facebook post. By the way, Facebook didn't have this edit post functionality until like last year, which is I think is crazy. But let's say you make a post and you want to edit a post. You can click on the edit post, and this div converts into a content editable box. And what it does is it allows users to edit the content of this page. For example, I can edit any kind of page with a content editable. So let's say I go into Facebook. I see this post. Right-click, inspect element. And all I have to do is to add a new attribute in the HTML, edit as HTML. And I'm going to add a new attribute, content editable. It's just like a class or an ID, and make it true. Content editable. So now it's true. Now if I can click on this, I can edit it. So content editable is really cool. I mean, it's not going to get reflected, but instead of using input tags or form tags, a lot of people choose to use this content editable instead of those tags, because you could just, with just a change in HTML attribute, you can achieve this effect. So that brings me to my last point, which is user. Some of you might become a UI designer. Some of you might become a front-end engineer. As a user interface designer, like your business card might say, like lorem ipsum, UI designer. That means that you are a user interface designer. Every decision that you make needs to start from user research. When I did a Piazza redesign, sure, I've used it as an instructor, I've used it as a student, but I'm pretty sure that there are people who know more than me when it comes to Piazza. So what I did was I approached the users, I asked our TAs, I asked some of our students, I asked some of my friends who use Piazza, and based on that survey, I made my decision. I like to really consider UI designer as like a psychiatrist. What you do is you listen to users' problems, people's problems, and based on that, you give them advices. So it's kind of like, just like how psychiatrists cannot give advice without listening to people first, as a UI designer, you have to listen to the users first and then make your decisions based on that. So maybe I should end this with my favorite code. I think a good user interface starts from the user. If you're designing what just looks good, you're an artist, not a UI designer. So to be a good UI designer, I highly encourage you to, instead of sitting in your room, coding the website, worrying about 3 pixels, go outside of your room and ask the people, should I move this to the 3 pixels to the left or not? Okay. So yeah, just to review, we talked about consistency, emphasis, hierarchy, call to action, performance, cost of action, design for failure, and of course, if you were to remember one thing, user-centered design. All right, thank you.